The discussion over obesity and weight gain is a complex one, and many a scientist and medical expert have investigated the various mechanisms behind why some people gain weight. One of those areas of research is in the brain-related hunger hormones that change our inclination to eat. So, in this piece of content, I'm going to show you some data from a study that investigated the differences in two key hunger hormones between lean individuals and overweight individuals. Stick around. Learn Your Body, a science-based education. The study I'll be referencing, as well as my notes and any following amendments, can be found attached to this content for your convenience. With that, a bit on the study design. The researchers recruited 29 participants to be included in the study, which were separated as 11 lean men and 18 obese men. The researchers then took blood measures of the two hunger hormones, agouti-related peptide known as AgRP and alpha melanocyte stimulating hormone known as MSH. Now, if you've never heard of these hormones or what they do, have no fear, I'll explain. Receptors in the brain region called the hypothalamus bind a variety of different hormones, but the melanocortin receptor is especially promiscuous, but binds the aforementioned melanocyte stimulating hormone, MSH. MSH is released from what are called POMC neurons located in the hypothalamus of the brain and bind downstream neurons, cells in the brain, to dampen appetite and hunger. However, agouti-related peptide, AgRP, does the exact opposite. When stimulated to be released, AgRP molecules will be released from another set of neurons known as the NPY, or AgRP-NPY neurons. AgRP will bind the same melanocortin receptors on these downstream neurons that MSH interacts with, inhibiting access to the receptors that would normally bind MSH. In doing so, they change the downstream signaling in these brain cells from a satiated state to a hunger state and increase the drive to eat. So, in summary, they are the opposite of one another. MSH inhibits hunger and AgRP increases hunger. So with that backstory out of the way, do overweight individuals have differing levels of each of these hormones compared to lean individuals? The answer is yes. Obese individuals in the study showed higher levels of MSH and AgRP compared to leaner individuals, which is intriguing. This might mean that there is some form of dysregulation, or it might mean that MSH and AgRP levels are in concert with overall fatness. Well, one aspect I left out until now is leptin, which is a primarily fat-secreted hormone, and it is leptin that binds these neurons. MSH secreting POMC cells and AgRP secreting AgRP-NPY cells. Leptin stimulates the release of MSH and inhibits the release of AgRP, and high fatness usually means higher leptin levels, which holds true here, as well as leptin levels are elevated in the obese individuals. However, as we saw, AgRP is not inhibited, which implies potential leptin resistance on the NPY cells. So then, it's a battleground between MSH and AgRP for which can influence the downstream neurons more, causing greater hunger or greater satiety, although surely other influences play a role as well. And keep in mind that this is a measure of blood MSH and blood AgRP, not local brain levels, which may differ. This all means that overweight men have elevated leptin, MSH, and AgRP, which signs for potential leptin resistance or some other form of dysregulation, or other factors are contributing. If you'd like to learn how weight loss affects these results, be sure to check out the next piece of content where I delve into it further. Thanks for stopping by. Cheers.